Here we want to solve the equation secant of theta times tangent of theta minus cosine of theta times cotangent of theta equals sine of theta. And the hint here tells us to multiply everything by sine. So I'm going to rewrite secant as 1 over cosine of theta, and I'm going to rewrite tangent as sine of theta over cosine of theta minus cosine of theta times cosine of theta over sine of theta is equal to sine of theta. And I want to multiply everything by sine of theta. And if I do that, we will get sine squared theta over cosine squared theta minus cosine squared theta is equal to sine squared theta. And this thing here, we can rewrite that as tangent squared theta. And then I'm going to add cosine squared theta to both sides. And the reason that I had thought to do that was now on the right-hand side, I have sine squared theta plus cosine squared theta. And I know that that's the Pythagorean identity. So we're going to end up getting tangent squared theta equals 1. And now I can take the square root of both sides. And so I get that tangent is equal to plus or minus 1. All right, so if I'm on the unit circle, I want to think about where tangent is equal to 1 and negative 1. So if I'm in quadrant 1, I know that here the slope of this line segment is 1, and this angle is going to be pi over 4. And then if I add multiples of pi to that, that's going to land me here. If I add pi, so that length is pi, that will also give me a slope of the line segment being 1. So we have that tangent of theta is equal to 1 whenever theta is equal to pi over 4 plus pi k, where k is an integer. And then the other location that we are solving for is when tangent of theta is equal to negative 1. And so that happens here in quadrant 2, and that is for the angle 3 pi over 4. And then that's going to happen anytime we rotate halfway around the circle. So we can say that theta is equal to 3 pi over 4 plus pi k, where k is an integer. And that gives us our solutions for part J. So for example K, I have 1 plus sine of x over cosine of x plus cosine of x divided by 1 plus sine of x, and that is equal to 4. And I want to find a common denominator, so I'm going to multiply the first fraction by 1 plus sine over x over 1 plus sine of x. And then the second fraction, I'm going to multiply by cosine of x over cosine of x. So if I simplify, let's see, I'll get 1 plus 2 sine of x plus sine squared x over cosine of x times 1 plus sine of x plus cosine squared x over cosine of x times 1 plus sine of x. And that is equal to 4. So now I can combine those and add them since they have the same denominator. So I'm going to have 1 plus 2 sine of x plus, notice that if I add sine squared x plus cosine squared x, that's the Pythagorean theorem, the Pythagorean identity. So that becomes 1 over cosine of x times 1 plus sine of x. And that is equal to 4. Now, if I add this one and this one together, I'd get 2 plus 2 sine of x, and then I could factor out a 2 to get 1 plus sine of x over cosine of x times 1 plus sine of x is equal to 4. And this 2 factors in the numerator and the denominator will cancel out, and we'll get 2 over cosine of x is equal to 4. And if I rearrange the terms algebraically, this would give us cosine of x is equal to 2 over 4, which is equal to 1/2. And so we are trying to find the x values where cosine is equal to 1/2, and that is going to happen when x is equal to pi over 3 plus 2 pi k, where k is an integer, and then also at 5 pi over 3 plus 2 pi k, where k is an integer. So that completes example K. Here in example L, we have 3 times tangent squared x minus square root of 3 tangent of x plus 3 tangent of x minus the square root of 3. And these have 4 terms on the left side of the equation. And so it looks like we might be able to utilize factoring by grouping. So in the first 2 terms, I'm going to factor out tangent of x. And then that's going to leave me with 3 tangent of x minus the square root of 3. And then in the second set of terms, I'm going to factor out a 1. And we're going to have 3 tangent of x minus the square root of 3. And then if I factor out 3 tangent of x minus the square root of 3, that will leave us with a multiplication by tangent of x plus 1. And that is equal to 0. And now I can use the zero product principle to set each of these factors equal to 0. And if we solve, we'll get tangent of x is equal to the square root of 3 over 3, and tangent of x is equal to -1. Now here I can apply tangent inverse to both sides. And if you do that, you'll get x is equal to pi over 6, and then plus, we know that the period of tangent is pi, so I could add pi k. And then there's the solution to that equation. And then we know that if I took arctangent or tangent inverse of -1, that would put me at -pi over 4. So for this equation, we get x equals -pi over 4 plus pi k, where k is an integer. And that concludes this example.